And welcome to our first R tutorial. This is the tutorial for projects 1 and 2. So welcome to R. One thing you can do is use a hashtag to comment out a line of code. This is really helpful, for taking notes. And it's really good to take a whole bunch of notes so you know what you're doing. Notice how when you don't have a hashtag in front, it thinks this is a line of like statistical code it wants to read, so we should put a hashtag in front of it. Also remember, I'm a bad speller. We'll fix that. So for this tutorial, we're going to use data sets that already exist in R. And we may do that for some of our projects. I know I've given you guys files for the first 2 projects, and I'll show you to load those as well. So what you want to do is you want to run this code. You can highlight it and click Run. See, if you click on history, it shows you that, like, okay, that's the last thing I did. That's my cat. You can also hit, I'm on a Mac, Command Enter, Control Enter, right? It'll help you run those data sets. If you are going to use the data I've given you, my suggestion is you download it and copy it to your laptop. If you run this code, File Data Choose, it lets you pick a file. So like I downloaded the stars, which is our project 2 data set, to my desktop, and I can click that, and that gives me its path, like the path for my computer to find it. And then you can comment this out and put it in here. So it's saying read this file. It's a CSV file, and this arrow says I'm going to call it, well, I don't want to call it reactors because it's the stars data. I could call it capital all stars, right? I just need to name it, right? And then if I run that code, we can see now in my environment, I have this stars data. Now we don't see all these library data sets I ran because they're already in just R. They're just there. So what this does is reads your data file. FYI, you can also put a URL directly into here and it should work. That arrow means we store it. If you use other coding or have other coding history, this equals sign will work. And by the way, I will be giving you this .r file, so you'll have it. So the data set we're going to use is irises. If you have a data set that's already in R, question mark in front of that data set will tell you about it. Note that that isn't going to work for that stars data I just loaded because that's not like built in. Also notice like tab complete is your friend. But see if I run that, where am I? Right, it doesn't work, right? There's no documentation for stars because it's not it doesn't have documentation, much like iris does. So we could run that. And this is Edgar Anderson's iris data. So who's a famous scientist, studied all these different irises. There are 3 different species. And it tells you about the references and all those things. So it tells you just a little bit about the data set. If you do head data set, what it's going to do is it's going to print you the first few lines of data. So here we have, right, we've got our unit, our flowers, like first flower had a sepal length of 5.1, 3.5. I'm pretty sure these are in inches, but it would tell you. Again, units are important. And what species it is. So that's going to tell you the first few lines of data. But that doesn't tell me how my data is saved, which is actually really crucial. So if you hit str, that means structure. And what that does is it prints out the structure of our data. So it tells me that sepal length is stored as a number. Sepal width is stored as a number. Petal length, petal width are all numbers. But species is a factor with 3 levels. Level 1 being setosa, 2 versicolor, and I'm assuming 3 is virginicea. Okay. So that tells us a lot about our data set. And for quantitative data, we can find our maximum and our minimum. So I'm going to hit Command Enter, or again, I could highlight it and hit Run. And that tells me that our minimum sepal width is 2, right? That's our minimum sepal width. We can also find our max sepal width, right? This sorts through the data for us. We could do this not just with sepal width, we could do this with sepal length. And notice I can tab complete. How nice is that? So our greatest sepal length is 4.3. Oh, that's our minimum sepal length. Let's also find our max. And I do a lot of copying of code, right? Copy paste is your friend. That's why I'm giving you guys this. And the max is 7.9. Okay. So that's how we could find the min and the maximum. Oh, and I forgot to copy in the histograms. So let me grab those 1 second and I'll be right back. So I'm back and now I have some information about histograms. Remember, histograms are quantitative data, so I can hit Command Enter and it's going to give me a histogram. Now for you, hopefully it should show up here. I don't know what's going on with my R today, but it's printing it out as a separate graph. So you can copy and save this. I have difficulty sometimes copying and saving it, so what I'll do is I'll take a screenshot, which I can't do right now because I'm using that to record. So here's a histogram of the iris sepal length, right? And it has this title, but it's not like great, so we could add some stuff. So main will tell me, I think it's main, yeah. Main gives me a way to give a title. So I could say irises by sepal length. So let's see how that changes our graph. Again, always make sure you have your parentheses closed. So here's my new graph when I run it, right? So now I have a title. That's great. I've got a frequency, but I could also label my X. My X is the sepal length. So I can say X, oops. So I could say X lab, that means X label. I could have just done tab complete, I guess. And that would be sepal length. Let's run that and see how my code changed. So now it says sepal length, iris by sepal length, frequency. I wonder if I can change that from frequency. Let's try. I could say Y lab, like meaning Y label, and I could change that to, and then you do need it in parentheses. That tells it it's a text. What if I said number of irises? Is that how you pluralize irises? Irises? Again, not a great speller. But we'll try. Command Enter. And look, it did rechange my label. One thing is this is kind of boring. It's very, very gray. So I can change the color. I could have columns red, or I can put in, I think I show you later, maybe I don't. Or you can put in a code to change that color, but let's go ahead and add this. So I'm going to put column red and let's see what happens. Oh, look, now they're red. Well, that's really red. I think there's also other built-in colors like cyan, beautiful, magenta. So you can play around with the color all you want. So we could do this for all of our histograms, right? I could add a title. One thing that's important when we're looking at histograms is to look at the shape, right? This is kind of like a symmetric, maybe skewed a little bit to the right. Let's look at petal length, right? Here we have like, oh, this is some outliers, right? And then we've got a little bit of skew to the right. And again with the petal width. But we could give these all titles and things like that. One thing I could do if I wanted, and this is a histogram by group, I don't have you do this in any of the projects, but I wanted you to see it since we're working with histograms, is I can make my graphs, C is concatenate, so it makes a column with 3 rows and 1 column. So it's always rows before column. I always think of like RC cola, rows before column. So I want to do a histogram of iris petal width by species, right? I want to look at the petal width for setosa, and then I want to look at the petal width for versicolor and the petal width for virginica. Do I repeat this one twice? I do. We don't want to do that. I only want these ones. So let me show you what this looks like. Hopefully this works. So here I have iris's petal width divided by just looking at the species Setosa, right? It knows to search for Setosa. So let's go ahead and run this. Notice how I have these commas after everything. I didn't have to write it in one long label. As long as it's separated by commas, it knows to keep reading and run the code. So here we have this one. So here's the petal width for Setosa. So now we're just looking at the one width. Here we've got petal width for, where'd that go? Petal width for versicolor. Notice how that's a little bit different. And petal width for veronica. See how they keep kind of shifting? I think my goal was, oh, I didn't run this code. So you have to run this code, and then it'll put them all in one column. Let's check that out. Please work. Thanks. Look at that. So then you can compare, okay, yeah, the petal width for Setosa is very different than for versicolor, than for virginica, right? They're very different. So this allows you to like compare between. You could also do this for petal length, sepal width, and kind of compare the species, right? We can already think that like virginica is going to be a bigger iris. So that's how you work with histograms. We can also work with box plots for that. I'm going to use a different set of data. I'm going to use this MT-CARS data. Remember that question mark tells me a little bit about the data set. So these are motor trend road tests from 1974, where MPG is miles per gallon, SIL is number of cylinders, D is displacement. I don't know what that means. Not a car person. We also have their weight, right? We have their gears, we have their number of carburetors. I don't think cars have carburetors anymore, but it tells you your sources, gives you some examples of data you could run. Remember, if I run head cars, it prints me the first list, and I could also do structure cars, MT-CARS. That tells me what the data set looks like. And they're all numbers, so that's nice. We can make bar charts, we can make histograms, life is good. So what I want to do is I want to make a bar chart of the cylinders. Okay, I want to make a bar chart of the cylinders. So let me hit Command Enter. Let's look at this bar chart. Oh, you know one thing I didn't do? I didn't make this so it was just one row and one column anymore. So let's do that first. Okay, and then we'll try and run this again. Now notice I've got cylinders that are 4, 6, and 8 cylinders. Those are my cars. But this isn't really what I wanted, right? I wanted a count of all of the 4 cylinders, which would be hard to count right here. It looks like 10. I wanted a count of all the 6 and a count of all the 8. So what I need to do is I need to put my cylinders, which only take on values if we see down here, of 6, 4, and 8. I'm going to put them in a table. So I'm going to call that table cylinders. That arrow means I'm committing it. I do table MT-CARS $cylinders, right? And that's going to create a table. So now I've created a table. You can also see in your history like all the things you've done. But it tells me I created a table. It also tells me when things don't work. Then I can make a bar plot of these cylinders, right? Here we have it. Look at that, right? I've got a bar plot. So this is the number of cylinders and their frequency, okay? So this is a bar plot. I also have this command plot. Let me show you what that looks like. Notice it gives you these skinny little lines. They aren't really bars. It's still readable, but it doesn't look like what I wanted. So let's go ahead and make this bar plot better by giving it some labels. So we could title our main, which is our main title, cars by cylinder. Maybe there's a better title. Am I spelling cylinder right? Yeah. We could label our X's, but you got to make sure you're out of the parentheses and add a comma. Let's do a tab complete. Yeah, X lab is number of cylinders. and a comma so it keeps reading. Then we could do Y, tab complete, so just hit tab and that'll pop up. Number of cars. And let's change our color to be yellow. That feels like a car color. And I've got to end this with a parenthesis, and then I can command enter or hit run. And look, oh, it knew yellow. That's a bright yellow. Cars by cylinder. One thing you might also want to do when you are all done working in your code is clean up your environment. So like I'm giving you this code, I would copy this cleanup code. But what this does is it just like unloads all the data, clears your environment. That way nothing that you've accidentally loaded will like interact with each other. So you can just run this whole thing and it'll clear everything for you. If you want to clear your environment, that's what I just did. If you want to clean your history, you can hit this little sweep button. Sweep means clean. Confirm clear history, yes. So here's your tutorial video. I hope it was helpful. I will be sharing this file and video with you guys later today.